Hey everyone, welcome. Today we're going to crack the code on two math concepts that, might sound a little scary at first, HCF and LCM. But trust me, they're actually super useful, and we're going to break them down completely. All right, let's kick things off with a little puzzle. So you've got these two ribbons. How would you even start to figure this out? Well, the secret is something called the highest common factor. And don't worry, we're going to get there step by step. So here's the game plan. We'll start with the basics, then get into our two main tools. We'll even find a cool connection between them, and then we'll use everything we've learned to solve a real problem. Let's get to it. Okay, first things first, we gotta start with the absolute basics, the foundation for everything we're gonna talk about today, factors and multiples. Okay, so what's the difference? Think of it like this. Factors are the smaller numbers that divide into a bigger number perfectly. They're like the ingredients. Multiples, on the other hand, are what you get when you multiply a number and get bigger and bigger. So just remember this. Factors divide up, multiples build up. Simple, right? All right, with that foundation, let's build our first major tool. It's called the HCF, or highest common factor. And yeah, this is exactly what we need for that ribbon problem. I know, highest common factor sounds super technical, right? But the idea is actually really simple. It's just the biggest number that can divide into your other numbers perfectly. That's it. The highest factor they share or have in common. And here's the easiest way to find it, right in action. We just list out all the factors for 12 and all the factors for 30. Now, which numbers are on both lists? We've got 1, 2, 3, and 6. And the biggest one? That's 6. So for our ribbon problem, the longest we can cut each piece is 6 inches. See? Problem solved. Okay, so listing them out works great for small numbers like 12 and 30. But what if you have really big numbers? Well, that's where prime factorization comes in. It's a super reliable method. You basically just break each number down into its prime ingredients, see what ingredients they share, and then multiply those shared ingredients together. Now here's another really cool trick, the division method. I know, it looks a little crazy at first glance, but the process is actually pretty clever. You just divide the big number by the small one. Then you take the remainder and divide the previous divisor by it. You just keep doing that over and over until you get a remainder of 0. And that last number you divided by, bam, that's your HCF. It's an awesome shortcut. Awesome! So we've totally mastered breaking things down. But what about the flip side? What if we want to know when things will line up or sync up in the future? Well, for that, we need our second tool, the lowest common multiple, or LCM. So let's try a whole new kind of puzzle. You've got two gears meshing together. This time, we're not dividing anything. We're trying to figure out when are they going to click back into their starting position at the exact same time. And that's exactly what the LCM is. It's just the smallest number that both of your starting numbers can multiply into. It's like the very first number that shows up in both of their times tables. And hey, just like we did with HCF, the simplest way to find it is to just list them out. You list the multiples of 4, 8, 12. Then you list the multiples of 6, 12. And look at that. The very first number they have in common is 12. So our gears will line up again after 12 teeth pass. That's our LCM. But again, what about bigger numbers? A process like this one, sometimes called the division method for LCM, is super efficient. You just line up all your numbers and start dividing by prime numbers that go into at least 2 of them. You keep going down the line, dividing and bringing down the numbers that don't divide until you can't go anymore. Then, to get the LCM, you just multiply all those numbers on the side and the bottom row together. So powerful. Okay, so we've got these two big ideas, right? HCF is all about breaking things down. LCM is all about building things up. They feel like opposites, but are they connected? Oh yeah, they totally are. There is this incredibly cool and elegant formula that connects them. Get this, if you multiply two numbers together, you get the exact same answer as if you multiply their HCF and their LCM together. It's an amazing shortcut. Let's prove it. Take 10 and 30. What's 10 times 30? It's 300. Okay, hold that thought. Now, the HCF of 10 and 30 is 10. The LCM is 30. So what's 10 times 30? 300. See, it works every time. This is awesome because it means if you know one, you can find the other really easily. All right, our toolkit is officially packed. We've got factors, multiples, HCF, LCM, the whole shebang. Now it's time to put on our detective hats and solve a real-world problem. Okay, here's our case. A fruit seller has these baskets of fruit, all with different amounts. The mission, should you choose to accept it, is to figure out the highest number of boys you can split all this fruit between so that every boy gets the same amount of each fruit and there's nothing left over. So, which tool do we pull out of our toolkit? HCF or LCM? This is always the first question you gotta ask, and the answer is always hidden in the words of the problem. You just have to look for the clues. And there they are. See those keywords? Highest number, equally distributed. Those are giant flashing signs pointing right at HCF. We're looking for the highest number, and we're distributing or dividing things up. This is a textbook HCF problem. So we run the numbers, 156, 221, and 390 through one of our HCF methods, and what do we get? 13. The answer is 13. That means the fruit seller can give everything out perfectly to 13 boys. It's amazing how once you know which tool to use, the answer just appears. So let's boil it all down. The main thing to remember from all of this is super simple. If you need to split things into the biggest possible equal groups, you need HCF. If you need to figure out when things will sync up again, you need LCM. That's really the core of it. So I'm going to leave you with a final thought. This stuff isn't just for math class, right? It's about patterns. Patterns of dividing things up and patterns of things syncing up. And these patterns are literally everywhere. So now that you know what you're looking for, where are you going to see them out in the world?